My name is Idris Adedamola Abdulhamid from the School of Computer Science and Engineering, the PhD candidate. So I'll be talking on Introduction to Blockchain. Learning objectives. After this session, the students will be able to define blockchain and its core components that are block, chain, and hashing. Also, the students will be able to explain how blockchain ensures data integrity and security. Also, be able to identify real-world applications of blockchain. First and foremost, while trust matters, cryptocurrency fraud example. Imagine a scenario, a world where blockchain or Bitcoin appears to be working just fine, but behind the scenes, the network is silently being split apart. Bitcoin is an example of blockchain relying on peer-to-peer network. This is an example of peer-to-peer network. That is, one computer is connected to another node. The peer-to-peer, that is P2P network, enables blockchain nodes to exchange block and transaction data. I will explain what the block and transaction is in the next slide. Prior attacks like border gateway protocol, hijacking, exploited routing level scenarios. If you look at this figure very well, this is a scenario of an attacking event, Canadian blockchain or Bitcoin attack. And on the right hand side, we have a network attack on Bitcoin. You can see here this TX transaction, and these are the nodes. We have the nodes 1, node 2, node 3. So this is an example of a Bitcoin attack. Why do we need to trust? Trust matters a lot in blockchain because blockchain is just the parent body that comprises of Bitcoin cryptocurrencies. It can be used for different approaches. Maybe you want to work with health data, education data, security data, and so on. So, but if you look at this example, this is an attacker. This attacker is trying to send a transaction, that is, do double spending attack. He's trying to share one transaction for many instances. You can see on the left-hand side is the merchant, who is the legal owner of the coin. On the right-hand side, we have the Bitcoin node, where we have the trusted and untrusted people. So this attacker is trying to divert the funds from this merchant, that is by transaction A to B. He's diverting it from transaction A to C. You can see, as you can see here. So this is an example of a double spending attack. So why do you have to trust? If you don't trust this network, then such an attack can occur. Why do we have to observe this trust? Partitioning facilitates majority, 51% attack, selfish mining, transaction logs or transaction suppression, cryptocurrency disruption, and more undiscovered exploits. Let me note, cryptocurrency is just one of the applications of blockchain. So as you can see, crypto is just a digital wallet, that is a digital currency that is spent on the internet. So from here, you can see illustration of a double spending attack in a cryptocurrency network. So P2P is peer-to-peer. Next, we still have to look at other cryptocurrencies that we have. We can see we have many like Bitcoin, Litecoin, Bitcoin Cash, Zcoin, Zcash, and so on and so forth. So based on this, we have up to at least 5,000 different type of cryptocurrencies. As you can see on the right hand side, these are their logos as gotten from the coin market cap. So from these cryptos, we have different technical terms like the buckets, triad buckets, and slot per bucket. So you can see from this research that was conducted, we have different ranking. That is, all of them have different ranking, but they have different names, they have different buckets, they have different triad buckets, and they have different slots per bucket. Next, we look at centralized versus decentralized transactions. In this particular slide, we have the word centralized, and we have decentralized. Then we also have transaction. It's worthy of note that decentralization isn't just about protocol rules. Protocol is just a rule that guides the operation of a particular system. It's not just about the protocol rules, it's about who you are actually connected to. So this is where we look at this scenario. For instance, we have this is a world map. We have Africa, Asia, North America, South America, Europe, and Australia. In this scenario, we have a victim node and we have the shadow AS. AS means autonomous system. Autonomous system is just a router. A router is a device that transfer packets, that is IP packets, internet packets from one place to another. Earlier on, we said we have different nodes on the network. As you can see here, these are nodes. So the router helps us to discharge the packet from this node to another node on the network. So having said that, we have to talk about the shadow AS. Shadow AS is like a fake IP address. Of course, we know that this attacker is having an opportunity of being on the network. We don't know who is who on the network, but this attacker can create many fake IPs using some technologies. So these IPs are known as shadow AS, or the IPs are generated by the shadow. The IP addresses are what? The shadow autonomous systems in this scenario. So you can see we have decentralization is just whereby you have many nodes that are connected and there is no one party that is guiding or that is in charge of routing the traffic. Blockchain basics. Here we talk about the keywords in blockchain. The block. This block is the digital container that stores validated list of transactions. Now, what's a transaction? Transaction is a transfer of Bitcoin value. In the case of blockchain, we have different applications, but in crypto, we talk about Bitcoin. As I said in this previous example, that we have different cryptocurrencies. So here, in this particular example, we are considering Bitcoin as an example of cryptocurrency. So if you look at this now, these are transaction. Transaction is a transfer of Bitcoin. It's trying to transfer this Bitcoin 10 BTC from A to what? To B. You can see this is the merchant transferring coin from what? From this attacker to the Bitcoin network. So this is a transaction now, trying to share the value of Bitcoin value. And when the participant gives the designated amount of Bitcoin they own to participants B, transactions are created through wallets, e.g. mobile wallets and digital wallets. So what are the characteristics of blockchain? Block itself, it's a digital container that stores the list of transaction, valid list of transaction through a consensus. You must have gotten a consensus. So what are the characteristics? Security, immutability, decentralization, transparency, and consensus management. Now, security in the sense that it has a protocol where we have the consensus. This consensus guides the way they communicate. That is, all of these nodes must agree. That's the key word. They must agree on that transaction before it's placed on the block. And once it's on the block, it can never be changed. That's the meaning of immutability. Decentralization means anybody can take action on the network, on their network. It's not managed by a single person. Anybody is not managing it. It's not owned by someone. Transparency. Node A can see what node B is sharing on the network. Node B can see what node C is sharing on the network. And lastly is consensus mechanism. Having said that, let's talk about some other keywords. In Bitcoin, there is a reliance on P2P, peer-to-peer. That is, what they mean by peer-to-peer is at a point in time, this node can be the server, at another point in time, it can be the client. So that's the meaning of peer-to-peer. There is no one central management. That's the meaning of peer-to-peer. So if you look at this, Bitcoin relies on peer-to-peer network to exchange block and transaction data. That is, partitioning attacks by attempting to split the Bitcoin network into isolated groups of nodes. Now, furthermore, we have the SHA, the secure hash algorithm. That's the SHA-256. Is a cryptocurrency algorithm that is being leveraged in this blockchain. Don't forget, we said security is one of the key components of the blockchain. So, a cryptographic hash function produces a fixed length of data, that is 256 bits, 32 bytes output from any input. Example, whether the input is 3 letters or 3 GB of data, the output is always 256. So what are the properties of cryptographic hash? It is deterministic, collision resistant, pre-image resistant, and avalanche effect. Having said this, it's deterministic because same inputs always give you same output. What this means is that if you input an input at a particular time, maybe time t plus 1, time t plus 2, you always get the same output. Collision resistant, it's hard to find two different inputs with the same hash. That is, if I use an input A with an input B now, at a particular time, there's difference for us. It's quite hard to find two different inputs with the same hash. That means it cannot be attacked. Image resistance, hard to reverse engineer. That is, they cannot use software engineering technology to reverse. They cannot see the input from the output. And lastly, avalanche effect. Small change in input will lead to a completely different hash output. So having said that, what are the real applications of blockchain, or particularly cryptocurrency in this scenario? Because we have many applications. If you are considering blockchain, we have it in our banking sector, healthcare sector, in airline reservation, agriculture, education, sports, and engineering. So having said that, let's look at the scenarios classification. If you look at this scenario, in a particular node, we have opportunity of 117 incoming connections and what, 8 outgoing connections. If you add this 117 plus 8, that would be 125. So the maximum number of bits you have there is 125 incoming connection and 3 outgoing connection. So 0 to 125, that's like 126. Although in particular 8 bits, the maximum number of bits you can have, maximum number of connection is 2 per 8, which is 156, 120, 120, 128. But here, in this particular Bitcoin scenario, by default, by design, we have 117 incoming connection. That means it's more pronounced to attack than not than others. So victim has 8 outgoing connection and 117 incoming connection. Look at all these are nodes. So these are the shadow IP addresses and the attacker autonomous system. Autonomous system is like a router. In this example, it's going to be an IP address. So it's going to be having a specialized IP address. So having said that, let's take some quizzes. Now, I would like to ask you some questions that, okay, which of the following ensures that blockchain data cannot be tampered with? I said immutability is one of the key features. A, peer-to-peer connection. B, hashing. C, central authority. And D, mining rewards. What do you think is the answer here? I will want you to give me an answer in the feedback section. Likewise, question 2, trust in blockchain. Why is trust considered a core requirement in blockchain system? A, because only government control cryptocurrencies. B, because users cannot verify blocks themselves. C, because if transactions are cryptographically secure, network attacks can still undermine integrity. And D, because miners always act honestly. Then the next question, real world impact. The airbus attack principles can also be applied to A, only blockchain. B, any peer-to-peer based cryptocurrency. C, only Ethereum. Ethereum is an example of a blockchain too, but it's an example of blockchain, crypto, public blockchain. And D, only private blockchains. So having said this, let's reflect on what we have said so far. Many attacks exist in the cryptocurrency world, e.g., airbus attack. Now, before we talk about this, if you look at the previous slide I shared a victim that is sending multiple credits to another, multiple transactions, diverting the traffic from the merchants to the network. So this is an example of an airbus attack, whereby it looks stealthy. Nobody can quickly determine it, and because of these connections that you have here, there is vulnerability in the network. 117 incoming connection for Bitcoin and 8 outgoing connections. So it's a big issue for us to tackle it. So, and lastly, I also said the airbus is extremely difficult to detect. Even if you can detect it, it's really hard to track down the perpetrator. This is by Min Sung Kang. So, having said that, I want us to have maybe, if you still have time, maybe to ask some more questions regarding what I've said so far. So if there's any question, you can contact me via this link. So you can just scan this barcode and get back to me. Thank you very much for the time.